everyone, Shrikant here, and today we're going to be looking at the Boomerang Nebula. It's one of the coldest places in the universe. Now, the reason why I'm doing it today is because this is summer season, right? And we want to go to cold places, but we can't, and I am sure you know why, right? Right? Yeah. So, I can still tell you about the coldest place in the universe. And like I said earlier, it's the Boomerang Nebula from the constellation Centaurus, about 5,000 light years away. Now, the Boomerang Nebula is a pre-planetary nebula, or a proto-planetary nebula. That means that it's basically a star at the end of its life. So let's assume that this is a star. So once a star has reached the end of its life, it runs out of the hydrogen fuel it needs to sustain. It needs for it to sustain. But once it starts to run out, it expands. Like you can see here, it expands. And then it releases like a lot of mass. It releases like a lot of mass that creates a lot of shapes. But the Boomerang Nebula is one of them. One of many that we have discovered. And its cause is actually pretty interesting. So the Boomerang Nebula is believed to be the cause of a collision between two stars. Now yes, stars normally do not collide, but a collision between two stars is, so let's say that when there are two stars basically orbiting each other, like you can see, okay? Like two stars orbiting each other, and more than half of the stars are, so it's kind of common, but then exotic, it's kind of common, yeah. So basically one of the stars reached the end of its life, and then the other one collides with it, creating a rapid expanding nebula that we know as the Boomerang Nebula. The Boomerang Nebula is rapidly expanding, and that has allowed it to reach the cooler temperature that we see. Now with this cool temperature, it is about only 1 Kelvin, and that's the reason. As it expands, the molecules get further and further away from each other. When it does get further and further away from each other, basically what happens is they start to become cooler, but they still stay gas. Another thing is that the Boomerang Nebula is kind of like a misnomer, and this is due to atmospheric distortion. See, atmospheric distortion is when we view an object like a star, its position seems here, but when it's actually here, we're just assuming that, because the light rays from the star have been refracted, and we see it as if it is here, but it's actually here. And it can even make objects extremely dim. And this is why when we see it in the low quality images, like when you see it in the Boomerang Nebula in low quality images, it looks a little like a boomerang. And actually, yes, in Australia it did look a little like a boomerang when it was first discovered by an Australian team of astronomers, and it didn't really look that much like what it does in the Hubble image. See, when you look at it in Hubble, it kind of looks like a bow tie, or it looks bipolar. That means, can you see here? It has two lobes. So, like this is a lobe and this is a lobe. So, it has like these two lobes. But there's another thing that makes the Boomerang Nebula crazy, and that is only if you zoom in close enough, you will then see that the Boomerang Nebula is really like a dust disk. Like, see, I'm drawing out the dust disk. It's really a dust disk. So, and then the two lobes that it pretends to have are basically more of light coming out from the star, and the dust disk that's surrounding the star is obscuring whatever light could come out from the other side. And this has allowed the Boomerang Nebula to look like this. And even though, yes, the dust disk does seem interesting, a lot of nebula have it, a lot of dark nebula have it, but this is a planetary nebula we're talking about. What planetary nebula we're talking about? It does have that dust disk. In conclusion, it is one of the coolest nebula. It's a fascinating object. It's extremely cold, and if you want to visit there, you please have to take a winter hat. This is Shrikant signing off.